spent a lot of time looking at properties of triangles in the last chapter. This chapter we're going to start looking at angles again, but not just of triangles. We're going to start talking about all polygons here. So besides triangles, give me some examples of another polygon. What's another name?
Hexagon.
Hexagon. How many sides? 6. What's another name?
Decagon.
Decagon.
Dodecagon.
Dodecagon. What's that?
12.
12. Yeah. Right. Yeah.
Wow.
I know one.
Says it doesn't even know.
We're going to look at angles. What, kids? Today, Michael, you ready?
Yes, sir.
What are we trying to answer?
What is the sum of the measure of the interior angles of a polygon?
Okay, so we're going to talk about two things to answer that today. What are the sum of the measures of the interior angles of a polygon? We're going to use the interior angle measures of a polygon. And then we're also going to talk about what else?
Angle measures. Exterior.
Exterior. So I'm going to jump down here to vocabulary way to the bottom, guys. An interior angle is obviously what?
Inside.
An angle that's inside, and an exterior angle is going to be an angle that is outside. But I want to talk about something here real quickly. Okay? What is an exterior angle, and what does it look like to a polygon? I'm going to make a drawing down here at the bottom. Ellie, just set it right here when you're done, okay? Okay, so I'm just going to draw a polygon real quickly. You do the same thing. Okay? How about we make a hexagon? Sound good? Here's my hexagon. All right? Hexagon because it has how many sides?
6.
Okay? An interior angle is going to be an angle that's where, kids?
Inside a polygon.
Inside a polygon. So if I mark off an angle right here, whoop. If I mark off an angle right here, maybe call this up here vertex A, this angle right here, that would be an interior angle. The interior angle is inside of that right there. So A is going to be an interior angle. Okay? Now, this is where things get kind of confusing. Okay, they talk about exterior angles of polygons. And now, you guys are very familiar with interior angles, but how about exterior angles? What do you guys think?
Just pretty much the opposite.
Pretty much the opposite, but actually there's a little bit of a twist to it. What we do is we look at everything in terms of a flat plane. Okay, and a flat plane, you can put a bunch of lines in a flat plane. And you guys know that straight lines have how many degrees in it? 180. So what we look at for exterior angles is this. I'm going to go ahead and I'm going to pick this side over here on the right. And what I'm going to do is I'm going to run a line or an extension through this that looks like so. It will look like the following. If I ran a line from here to here, kind of like this, that line or that segment is part of a line. Okay? That segment is part of a line. And what we end up seeing right here, guys, is this. This angle right here that forms off of this. Anybody want to guess what kind of angle that's called? That's going to be the exterior angle we're talking about. Okay? So it's not going all the way around on the outside. It's basically saying if I would run this side completely straight through on a line, the exterior angle is going to be that angle right there. Are you okay with that?
What would it be called if you were doing this thing?
So it's going to be called the reflexive angle. Okay, what's the reflexive angle? In other words, go the other way. Okay?
Are we using that?
Nope, not today. Eventually, but not today. Okay? So understand that an exterior angle to a polygon is like, okay, if I had this side and extended it, what would this angle be right here? What would that look like? Okay? So understand what exterior and interior angles are for polygons. I think we're pretty good with that. So let's get to the gist of this today. First of all, in a polygon, what's a diagonal? Volunteer to read that? Go ahead, Katie. Diagonal.
A diagonal of a polygon is a segment that joins two non-consecutive vertices.
Okay, so a diagonal is anything that goes from one corner to another as long as the two corners aren't consecutive. So it might look like so. It might look like, I don't know, what kind of polygon you want to use.
Triangle. Right triangle.
How about a pentagon?
A five-pointed star.
Here's my pentagon. Okay? I don't care what the pentagon looks like. Okay, but make sure it has how many sides. Okay, a diagonal is simply going to be any diagonal that can go from one corner to another corner as long as that line is completely within there. So I might have something that looks like this. As is this a diagonal? Is this a diagonal? Yep. It could be. Okay. Can I go from here to here as a diagonal?
No.
No. Can't go from one side to a consecutive side. I got to go from one corner, skip a corner, and go to another. So those would all be examples of diagonals in any polygon. Okay. If I pick one point, go to another point. As long as that line is completely inside the polygon, that would be considered a diagonal.
Well, it makes a star if you will.
It would make a star if you did all of them right, because off of
Wow.
off of each diagonal or off of each vertex, how many diagonals could you have?
2.
Yeah. Okay. And we'll talk about that here in a little bit. Okay. Next one says what, kids? I have an equilateral polygon. All right, let's do this. Maybe I have an equilateral polygon that is
Triangle.
Square.
okay, square. I like square. Equilateral means all sides are what?
The same.
The same. So I indicate this by saying equal, 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 equal. Okay? So equilateral polygon means all sides are what? Okay? What's the next one here?
Equiangular.
Equiangular polygon. What's the definition of equiangular?
All angles in
It's
the
an
polygon.
all the angles are the same.
Okay, maybe I don't know if they look the same, but what if I did this? I would say this, 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 this. I mean, they're obviously not equal. It's not equal, but what if I put those marks in there and tell you, oh, all those angles are equal?
Then they're equal.
They're equal now.
Okay, have I indicated anything about sides being equal?
No.
So the only thing I can say about that polygon is it would be what kind of polygon?
I'm really mad at
Regular.
Say that again.
Regular.
Well,
Angular.
wouldn't that be equiangular?
Oh, that's what we were
Okay,
on.
next one is regular. Regular polygon is going to be what's convex. It's both what and what?
Equilateral and
So sides are equal and what else?
equivalent.
Yes.
Use the square for that.
So for this one right here, let's do a real hexagon, a good one maybe. No, let's do,
Triangle.
Why
would you do triangle?
Let's
do a 5-point star.
let's do the Pentagon.
Why would you do a triangle? You can't do triangle. What about a 6-point star?
Ooh, I don't know about that.
Is that like a thing? Is that a thing? It would have to be a thing.
Oh yeah, it's satanic.
Oh, really? I'm sorry. Oh, yeah. That's right. Well, then we'll have to go 7.
Okay,
There's dumb stuff in my
what do you think there, guys? Regular means all sides are what? And what else? All angles are going to be equal. Okay? All right? So you should be able to know that. And then the next thing that I have up here, kids, is polygon. You should be able to know what a polygon is. A polygon is any figure that's described by a finite number of what kind of sides? Straight line segments connected to form a... Okay, what's this word convex mean again?
The things are pointed outwards.
It's a
Okay,
convex.
it's not dented in, okay? A polygon is going to be, let me give you an example of what a polygon is and what a polygon isn't, okay? So Jacob has this fascination with a 5-pointed star today, right? Okay, this is not a polygon because, first of all, does it have straight line segments as sides? Okay, this is not a polygon, okay, because if I pick a point right here and right here, guys, if I drew my line segment between the two random points within that 5-pointed star, would the line segment that connects that stay completely within the boundary of it, or would it pass outside of it? Pass outside. This one here needs a visa, okay? All right, so this is not good. So this is not a polygon. It's not a polygon because it's not, what's the word here? It's not convex, it's concave. So all polygons must be convex, okay? So if I wanted something that was 10-sided, it would look like this. Kind of get the idea? That is a polygon because, I don't know why it did it that way, but you get the idea. Boom, boom. It's not 10 sides, but
Dang, it didn't do its job.
I'll try again.
I'm drawing a circle. Is a circle a polygon?
No, because the sides aren't what?
Is it stop sign a polygon?
Yes.
Should I add?
Yeah. You're talking over there.
This is convex right here. So this is a polygon.
Well, you could get it like infinitely close to being a circle, and it would still be a
I don't know how to
polygon.
make a star.
But it's not.
But it could be because,
But it's not.
like Mr. Jackson says, like 7.9 repeating is 8.
Mr. Gaston.
I was on the grind today.
I was too. But Mrs. Gates came. I was on the phone.
Well, if you have like a million sides on a circle, it's basically, yeah,
But it's not.
But it's
but
not.
it's not a circle. But do you think like
So how's
like
this going?
0.9 repeating equals 1?
That's what he says. He says it is.
It's not
I'll
because
do
it's
the.
0.9.
Do you want me to come up there and do this for you on the floor?
Dude, those carrots look moist. Nothing wrong with
I'll have a discussion with you later, okay?
Yeah.
Wait,
After
what
we're done with
seasoning
the-
do you put on?
After we're done with Johnny's salt.
Because he made a big
Oh,
argument
it's
that
salt?
it is one.
Who puts salt on
And
carrots?
he said it is 1 because there's nothing in between.
It was salt
You can't
like
get
a-
any- you can't divide it. So
Cucumber.
This is all.
You guys
Radish.
put salt on
Radish.
your watermelon?
Salt
You guys
on
put
a
salt on your
radish.
carrot?
No, it's parsnip.
I put salt on your watermelon.
I don't know.
Carson, do you put salt on your watermelon?
Carson, you put salt on
Yeah.
radishes?
So I have a question. If 0.9 repeating is equal to 1, we do the same thing. Should I put another 9 at the end of it?
Yeah.
And I have 1? No. I'm going to look at this from a remainders aspect with you guys at the end of the hour, and I'll show you what's going on with that, okay?
that,
Alright.
we should have a debate on the last day of school, you and Mr. Gatsby chapter.
There's a remainder aspect. I understand, look, I understand why you call that 1. I get why you call it 1, because it's all about changing stuff from decimals to fractions or rational values. 0.9 repeating is a rational value. I get that. And there's rules from mathematics to show what that rational value would look like as a fraction, which does turn out to be 1 with those rules. However, there's a flaw to that. Okay? All right? Yes.
You have.
Yeah. Okay? All right. You guys know what convex means, right? Okay.
It's probably doing the
Which one of these is convex? Is this convex? Is that convex? Is this convex? Okay. All right, so let's rock and roll here. Let's figure that stuff out. Okay? All right, next page then. You should have everything. You should have everything there.
We're number 1 now?
Whoops. Okay, next page. Let's get rolling here. So, up here there's a core concept. This is very important today, kiddos. Okay, I want to show you this right here. Let's pick a figure, kids. How about, should we go Pentagon or should we go Hexagon? Well, I'm going to use the concept of triangles to help us understand this formula. Pentagon? All right, let's go Pentagon. Just make a best sketch you can. Hexagon, you want a hexagon?
No, just Pentagon.
Pentagon. Okay, Pentagon it is.
How many sides is the dodecahedron?
Right?
Yep.
I thought it was 200.
All right, here's my
Keep it wrestled.
here's my Pentagon in here, kids. Right? So let's just talk real quickly. There's a core concept up here that says, what's the name of the theorem, kids?
Polygon interior angles.
Polygon interior angles theorem right here. Very important. Okay, what does this mean? What does this say? All right. Very important. This theorem says the sum of the measures of the, and I'm going to underline the word, am I inside this or outside of this?
Inside.
Okay. Of a convex n-gon, I'm going to tell you this right here. N represents number of sides here. So in the example we're going to use on the right, what's n equal to? Number of sides. So what would the n value be? It would be 5. Okay. You guys know that in a triangle, the interior angles add up to how many degrees? 180. Well, my question becomes this. How many degrees does the inside of a pentagon add up to?
Well, let's see.
360?
We learned this before.
Okay, let's take a look at this. Here's how this would look.
180.
Add 180.
What's the formula say it would become? N minus
Oh, so the sides minus 2
times what?
180.
So the number of sides minus 2 times 180. Why is that? Well, here's why it is.
Because you should make it to a triangle.
Yeah, if I take this right here, if I pick a point and I draw a diagonal from here to, say, down there, and then from that same point to another,
Then it makes 3 triangles.
yeah, you've got triangle 1, triangle 2, triangle 3 there, don't you? Okay? So again, the question says this. You guys know a lot about triangles.
Yes.
You know that the sum of the interior angles of a triangle is how many degrees? 180. When I take a pentagon in this example and divide this up using diagonals, how many triangles are formulated into that pentagon? 3 of them, where each of those would be how many degrees on the interior?
180.
So I'm really going to take 180 times what? Well, check it out here, guys. Is my formula going to work? It says the sum of the measure of the interior angles of a convex n-gon. In this case, what kind of gon? Pentagon. So how many sides?
5.
Is going to be n minus 2 times what?
180.
What is 5 minus 2? Do I get my 3 triangles here?
Great.
Let me ask this question. If I had to say you have a 7-sided figure, what times what to figure out the number of degrees on the interior?
180.
5 times 180. Okay, it's always 2 less than the number of sides times 180. So in example 1 right here, let's talk example 1 because this is what we're applying right here. Okay, and by the way, let's just go back up to this. Let's go back up to this. This would have been 5 minus 2 times.
I can't see that.
Yeah. It's
This would have been 5 minus 2 times what? Okay, what's 3 times 180? 540 degrees. So how many degrees are in a pentagon on the interior? You would say 540. Okay, 540. Okay. All right. So let's talk about this right here. It says finding the sum of the angles of a measure in a polygon. It says find the sum of the interior angles for a decagon. Well, a decagon is how many sides, kids? Decagon is 10 sides.
10 minus 2.
So you go 10 minus 2 times what? I'm not sure on it. Is that like 1,080? No? 1,440?
Yeah.
1,440.
1,440? Okay, so how many degrees on the interior of a decagon? It would be... Okay. What do you guys think? You okay with that? Any questions about that? Okay. Again, why 8 times 180? Why not 10 times 180?
Because 0 minus 2 is
Yep, take the number of sides minus 2. You bet. Okay. All right. Well, let's talk. I like example 2. I think this is great. Example 2 says finding the number of what?
Unknown.
Yep, so we're going to find the number of, really, what's it say? Okay, it says the sum of what?
Measures on
Of the interior angles of a convex polygon is how many degrees?
1,000.
It says classify the polygon by the number of sides. Well, gosh, I don't know the number of sides, but I know the interior angles is 1,800 degrees. So here's the deal. We have 1,800 degrees.
Divide.
That's going to equal, by definition, how do you find the number of degrees in the polynomial? What's the formula?
Hey, there's 12 sides.
Number of sides, n minus 2, times what? Okay, so here's how we're going to solve this, kids. First thing I'm going to do is get rid of that 180 on both sides. So we're going to divide both sides by what? All right, divide by 180. Over here, you guys agree that this becomes the following? What's 1800 divided by 180? 10. So 10 is equal to?
And minus 2. Then you got plus 2.
You bet.
And
So if I add 2 to that, what do you get?
A dodecagon. Dodecagon.
Yep, you add 2 to this, and you've got 12 is equal to n, which is a 12-sided figure. What's the name of it again? Dodecagon. Decahedrons are 3-dimensional.
Oh.
Okay, like a ball.
Yeah.
Okay, well, what do you guys think? Can you handle this?
Yes, sir.
Okay, I want you guys to try example 3 on your own. I want to see what you come up with example 3 on your own. So talk with a neighbor, see what you come up with. Okay, talk with a neighbor, see what you come up with. We have to find that unknown angle x. 2, 3, 4, 6, 4, 20. Okay. You show of hands when you maybe have a solution or an answer, or 1 in this row, 1 in this row, 1 in that row. Who wants to kind of describe to me what we did here, what process you took?
Count the sides.
Okay, so count the sides first. So it looks like we have how many sides, kids?
6 sides. Minus 2.
Okay, so we've got 1, 2, 3, 4, 5. We have 6 sides. So we're taking 6 minus 2, you said?
That's 3 times 180.
Times 180. So let me see. My North of Highway 3 math skills tell me that this is 720. Okay. So you're telling me all this has to add up to what? Okay.
So you add all the angles that you know.
So add the angles that you know here. 118, 111, 124. What'd that all add up to? So all the angles, so I could say x plus all the angles that you added up was what, 613?
Yeah.
That should equal what value?
720.
700 and... Okay, now what?
So you subtract 720 by 613.
And what'd you guys get?
107.
107.
So if I threw 107 in there, and I added all the angles up there, it should add up to what?
720.
Why 720 again, kids?
Because you take the number of sides minus 2.
Because, again, why?
Take the number of sides minus 2 and the times by 2.
Okay, so the number of sides minus 2 times 180 is the sum of the interior angles. Very good, you guys. Very good. How many got 107 there? Just curious. Feeling good about it? Told you today was pretty easy, didn't I? All right, let's head off to page 3 if you have everything. Is it okay to go?
Yes.
Ooh. I'm going to challenge you right here. You guys go ahead and see if you can get this one. It says finding angle measures in a polygon. It says a polygon is shown. Part A, is the polygon regular? Explain your reasoning. And then find the measures of A, B, or I'm sorry, B, D, E, and G. Well, kids, I have a question. Is this going to be a regular polygon, yes or no?
No.
All right, I'm hearing yes and I'm hearing no.
No.
No people, argue.
The angles are different, so the sides. Right.
Okay, a regular polygon has to have all equal angles, right? So I can say no, not all.
Angles are equal.
Not all angles are equal here, are they? Okay, now I have a question here, kids. What's true about this, this, and this? Then aren't B, D, E, and G the angles you have to find? Okay, see what you come up with. I'm curious to see what you come up with here.
One, two, how many sides is this? 5 times 180. You can do it like that.
No, 7. 7 sides.
You got 900 and then you got. So, there's 7.
Yeah, I know. It's like 400.
No, 4x plus.
You figured it out. So you're saying all these I didn't even notice That's pretty dynamic. Yeah, I'm gonna need to contact someone to help us because that is not yesterday. Okay.
Hey there.
I have mine, but I haven't had to read mine, so. What? I already turned him in and checked it.
Oh.
Bam! I had it 5 out. You better not read it. Matt hasn't done it. He was going, so step your game up. Why would I do that one? I didn't comprehend anything that we learned. I just like literally wrote in the book and was like writing down. Oh, that matches.
Okay, well, how about part B? Do we have an answer?
Yep.
What'd you guys get? 125 degrees. Do tell. I agree with you, number one. Volunteer. Someone I haven't heard from yet today. Want it, Ty?
Yep.
Audrey, you make sure he's right, okay?
Alright, I will.
All right, Ty, I'm listening.
Okay, so I took 7 minus 2
Okay.
to get 5, multiplied that by 180, and that's like 900.
So since there were 7 sides, we had to go 5 times 180 by interior angle theorem, right?
Yeah.
900 degrees total in this. Okay.
Then I added up 100, 160, and 140.
Okay, so this, and this add up to how much?
Like 400 maybe, 500, something like that.
I was thinking 400 maybe. So you got 400 degrees between angles A, F, and C, right?
Yeah.
So I'm going to take that out of there. That means the angles that remain, the 4 angles that we're looking for, have to total how many degrees?
500.
So angle B plus angle D plus angle E plus angle G must equal how much again?
500.
But what's true about all those angles given the diagram?
They're all same.
They're all equal. So if all 4 angles, which are equal by diagram, add up to 500, then what must be true about the interior angle measure of each of those? They're the same, Ty. How'd you get that 125 value then?
I divided 500 by 4.
Divided 500 by 4, which was?
125.
Okay, so since B, D, E, and G were equal, we divide by 4. You got 125. You guys help me out. How many had 125 for that as you worked through that with your partner? Okay. I heard good discussions there. That was good. That was good. Okay. All right. This interior angle theorem, are you okay with it?
Yes.
Okay, what's the formula for the sum of the measures of the angles on the interior of any regular polygon, but any polygon?
N minus 2 times 180.
I'm here at n minus 2 times 180, where n represents what?
Number 7.
Very good. Okay, good. All right, so we're good on interior angle theorem, so let's jump down to this next core concept right here, which states, not an interior angle theorem, but what? Exterior angle theorem. And this one, yeah, you know, this is going to be important. Not as important as the other one, because let's just read through this real quickly.
Hey guys, let's just all acknowledge that Casey starts delivering pizzas tomorrow.
This is like a great day in my life. However, I asked them if they would deliver. I asked them if they would deliver to a dead-end gravel road about 7 miles out of town. And you know what they said?
No.
No. And I was like, darn.
What about 2 miles?
That's not that far out.
They said city limits. Is what they told me. Okay.
Just give them their address. Give them your address.
Oh, yeah, well, I guess I do vote.
Then the next thing they said, well, maybe one of your delivery people is a good friend of yours, and maybe they will bring it out to you. So I don't know. We'll see. Okay, guys, core concept, polygon exterior angle theorem. This is actually a lot easier than the other one, and I think you guys have a great handle on the first one. So this says right here, the sum of what? Of the of a
On the
What angle at each vertex?
okay, let me show you what this means. I'm going to divide this into a couple of drawings. I'm going to put some numbers to this right here. Now, first of all, we need to understand what an exterior angle is. I'm going to start with just a triangle, maybe a right triangle. Okay, how about this? Okay, and then I'm going to divide. I'm going to put a dividing line right in here, like so. Yeah, because I'm going to do another shape over here. So put a triangle over here. Guys, we know triangles total up to how much? Okay, I'm going to put a right angle here. I'm going to call this up here 50 degrees. Let's call this 40 degrees. Okay, are you with me on this? Okay, now if I would make an extension off of each of these right here for an exterior angle, an extension this way, an extension this way, and an extension this way.
Oh, we already know.
Okay, watch what happens here. Okay, they want to know the sum of the exterior angles. Well, first of all, if this is 90, what's this angle have to be out here? Okay, so I have an angle of 90 degrees right here. Okay, if this is 50, what's that make this exterior angle? Because that straight line would be 180, so this would make this 130, right? If this is 40 degrees out here, what would this be? Okay, so what I need someone to do here quickly is to take 90 plus 130 plus 140 and see what that equals. Okay, so the sum of the exterior angles for a triangle here looks like what? Okay, let's try another one here. Let's try a different shape.
It's always double. That's what I'm thinking right now. I'm not sure.
I'm going to go polygon that is, I'm tired of Pentagons today. Let's go Hexagon. Pentagon's probably shut. The Pentagons should probably be shut down today because the government shut down, right?
I wonder how much money we're saving. Hopefully we're.
I think we're losing actually.
Yeah.
Okay, it's okay. You know the thing
It's
that's
about to go down like a 0.5% in the.
is it?
Yeah.
What is supposed to go down?
Hey, Mr. Parson.
Yeah.
Did you know that if we raise minimum wage, we would actually increase the economy?
Yep.
You know, if we just order Big Macs in the White House, everything will be fine.
I think they would like
We should order.
I was upset. There was no Wendy's. I'm a Wendy's guy. I like Wendy's.
Yeah, everyone's like mad that the football players didn't get a good meal, but then the football players are like,
Yeah.
it's okay.
I would rather have
They said
We
it's
should
like
order
the
some
best meal.
McMurders.
Well, dude, when everyone was talking about burgers, I thought they were talking about like hamburgers on the grill, you know, not like Big Macs.
Yeah, don't.
That's the problem with pizza.
Well, as long as they get as many Big Macs as they want.
How do you feel about that egg?
Force them to eat it.
Well,
Because Big Macs are
here's my
so
thing.
small. I can eat like 4.
Do you like Big Macs?
That's a Beyblade right there. If I was.
my deal is if I don't have to pay for a meal, I'm happy.
Yeah.
So that's why I like coaching so much and going to McDonald's afterwards. Because like after a game or something or after track meet, we go to McDonald's and I walk up and say, "Hey, I'm a coach." They're like, "Okay, you can eat for free."
Really?
Yep, that's one of the perks.
You
Okay.
may actually.
Actually, do. Yep. Okay. Hey guys, do me a favor. Let's consider this. Everybody, stay with me here. Everybody, stay with me. Let's consider this to be a regular hexagon. Okay. So first of all, tell me how many degrees are in a regular hexagon by interior. So we're going to go what times 180? 4 times 180 is what? What's 2 times 180? 360, and then 3.
720.
Okay. So here's the deal. Take 720 and divide it by 6.
120.
Okay, each of these angles around here is 120, kids. Each of these angles down here, 120 degrees on the inside. Okay, let's talk about this exterior angle thing then. Well, here's the situation. If I have a regular pentagon, regular hexagon, if I have a regular hexagon, every angle on the inside is how many degrees? What would that make this exterior angle right here? What would that make this exterior angle right here? All my exterior angles are going to be what?
60.
So now it's going to be half as much. Sometimes it's twice as much, sometimes it's half as much.
I have a question, kids. If you go with the exterior angles, how many 60s do I have around here?
66.
There's 6 60s, right? So what is 6 times 60?
360, brother.
What's the exterior angle measure sum again? Okay, so that's what this core concept is saying. It's saying if you have any polygon, the exterior angles will always add up to what? Don't care if it's 28 sides, I don't care if it's 3 sides. Every time we look, hey, what happened in the triangle right here, kids? 90, 130, 140, what did it add up to? Because they're exterior angles. They're basically the supplement to the interiors. The supplement to the interior angles, the sum of the supplements of the interior angles will add up to 360 every single time. That's what's going on here, okay? So, check this out. You guys take a look at example 5. I want you to do example 5 on your own, okay? Do example 5 on your own. It says finding an unknown exterior angle measure. You guys go. Find the value of x in the diagram. Okay, what kind of angles are these first?
So 265 plus 62 is going
That's a 5x
Where'd you divide it?
24. That's fine.
That's so weird.
Hey, give me a show of hands when you think you have it. Okay, first question. What's going to be true about all these angles right here? They have to add up to 360. So, what did everything here, what did all the known values add up to? 255? 265. So do you guys agree that really I can say 5x plus 265 would have to total what value here? It's on the exterior, so you're going to total 360. So I'm getting 5x equals 95 when I do this. Guys, I'm pretty sure that when you take 95 and divide by 5, what do you get?
19.
How many of you guys have 19 for that x value?
Yes.
How many of you just said, oh, okay, maybe you did it this way. You just added all these up, subtracted from 360, and said, oh, this angle has to be 95 degrees, and then took 95 divided by 5. Okay?
I did 360 minus 62 minus 35 minus that, and then divided it.
And then
Same.
No,
Yep.
I did all that.
Yep, that's cool. Okay? Again, are we clear on that?
Yes.
Do you understand the difference in theorems when we're on the inside of a polygon and when we're on the exterior of a polygon?
Yeah.
Okay. All right, so let's look at this last example, kids. I'm going to let you try this on your own. I want to make sure that you guys can do this. So they're talking about a face, all right? So up here pictured is finding an angle measure in regular polygons. It says each face of a what here? Dodecahedron is shaped like a what, kids?
Regular Pentagon.
Okay, it says find the interior angle of each regular pentagon. Find the measure of each interior angle of the,
Regular Pentagon.
I'm sorry, exterior. You guys do that quickly. Find each interior, find each exterior. Yeah, it's just what kind of shape? Really, you're just looking at. You're really just looking at this side right here, aren't you?
Seems like a 6'5". This is a regular. Yeah. This looks like a soccer ball.
Perfect.
You want someone to travel?
What? Yeah. Thank you. Happy birthday. Thank you.
I got What? I win.
What'd you guys get for exterior and interior angles? What's the interior angle on that?
108.
How'd you get 108?
540 divided by 4.
So part A, you had to do. Where'd the 540 come from?
3 times 180.
Why 3 times 180?
Because 5 is 2.
5 sides minus 2 times 180
Equals 500.
is 540. But why did where'd the 108 come from?
Because there's 5 sides, so you take, since they're all equal, 540 divided by 5.
Got to divide that by 5. So each angle on the inside is 108, right?
Yes.
Well, if this angle here is 108 degrees, how are you going to find an exterior that might run off of that right this way?
180 minus 1.
Yep. Guys, the interior angle and the exterior angle have to add up to 180 every single time. So what we're saying is this. The way you find the total number of degrees up top here is 5 minus 2 times 180. That was 540. But how many equal angles do you have on the inside? There are 5. So what I'd like to do is really say, well, each angle in here is how many degrees? Maybe this is 108 degrees right here, right? If I run an exterior angle off of that straight out this way, what's its supplement to 108? 72. So the exteriors are 72. By the way, somebody, how many exterior angles would there be to a pentagon? Take 72 times 5. Does that hold true?
360.
Okay. Kids, interior angles, exterior angles, you know the difference. Okay, I sent out an online 7.1, so you have about 10 minutes to get that started. Second thing I'm going to tell you is if you still have to finish up the test, you'll be making arrangements with me soon so I know what you're doing. And then if you're going to make any corrections on your test, January 23 is your deadline for that. Leighton. Do what? Yep.
Yeah, you do you, Leighton.
All right, so let's get rolling, okay?
Can I try to get like some of my tests finished?
Yeah.
Oh.
I think I have it in here, Alina. So, guys, I'm going to have some people finish tests up, so these last 10 minutes, make sure it's quiet, okay? Jacob, you want to work on it for a little bit? Who else wants to work on theirs for a little bit these last 10? That'd be good. Come on up. Audrey, you want yours now?
Can I just wait to start?
Yep. Matt, you want to get started?
Wait, is it gonna be a
You're a loser. I freaking won. I won. Alright, rematch.
So I'd be able to do it. Matt, wait, so when we have time to look at the costume,
Possibly for a little
we
bit.
start out tomorrow, so just go ahead and come in during study hall. Sure.
Yeah, go ahead and do as much as you can now, and then we might have some time tomorrow also, Ty.
Do you have one?
Yep, you want to get started on that, Matt?
Matt, just come in during study hall tomorrow.
We didn't.
Matt, I want
Neither
you
of
to
us
cross
won.
off. Okay, so down here now, you can have fun, you just have to choose one of them, okay? And then, I already crossed off the ones you don't need to. But I do want you to do 7. 7 is the open, okay? Got it? Go ahead. I stop the recording yet?
No.
Yeah, we're gonna.